and ref1 equal to x. So what you are doing, you are creating an alias to x, and alias name is ref1, right? So because reference variable is nothing but an alias. Now I originally had x, and now I've created an alias to x, and the name of the alias is ref1. So reference to variable x. So instead of x, I can even use ref. Alias is that is the idea, right? You can use either its original name, which is x, or you can even use the alias, which is also referring to the same location as that of x. So in this case, that is in the reference variables, concept. So ampersand does not mean address of; it means reference to. Reference to. I mean, address of is the C definition of ampersand. So therefore, I just wanted to tell you that it is not C, it is C++. So the definition is not address of, but it means reference to. Okay. So next point. References are treated as constant. We will explain this idea with examples, but try to understand that references are treated as constant, or try to remember references are treated as constant. That means what? You cannot change that. So constant is something which you cannot change, right? So references you cannot change. You cannot change means the second statement very clearly says that they must be initialized at the time of declaration, and once initialized cannot be reassigned. Agreed? The moment you create an alias to x, for example, you had the previous example, if you say you had x and then you created an alias called ref1, and this alias is for x. So once you have created and assigned the value, that's it. You cannot reassign ref1 to another variable, say y. Cannot do that. So therefore, ref1 is treated as constant, means you cannot reassign. References must always be initialized with a valid object. So always, the moment you create, you are supposed to initialize also. So that's one point. Next point says, unlike pointers, which can hold a null value, there is no such thing as a null reference, right? So this is one improvement. What I'm saying in C we had null option, or that is a pointer which stores null, but in references we don't have such a thing. So int y equal to 43. So just observe this small series of statements. Int y equal to 43. Int address of, that is a reference, ref1 equal to y. So you can do that. It's a valid reference. It's a valid reference. Whereas we cannot just declare and leave it. The last statement, if you observe, it is you are just declaring a reference variable and you are not initializing that to anything. So it is invalid. Okay. Whereas in C, we can simply write a pointer and say equal to null. That's possible. In this one, it is not possible. So next point, a reference cannot be redirected or reassigned to reference another variable. But whereas pointers, we can do this, but in reference variables, you cannot do this. So this example shows that point very clearly. So int a, just observe the simple C statements. Int a equal to 8, b equal to 2. And you created a reference variable called ref2. And that is aliasing a, or integer, or the variable a. Next, if you write ref2 equal to b, so what will this do? What will this do? What are you expecting? Few of you can answer. The last statement, what will be the effect of the last statement?
So error, compilation.
Okay, any other answers?
The value of given become equal to 2.
Sorry, I could not hear it. Value of
A will become 2.
value of A will become 2. Value of A will become 2. Okay. Any other answers?
Sir, the value at location 8 will become 2.
That's as good as the other answer which said the value of A will become 2. Variable
No,
A value
no, sir, the
initially
value
is
pointed
8.
by 8, like 8 in the memory, that will become,
No,
the value of A
see,
will remain the
A is not
same.
a, I mean, 8 is not a point. So, can you come again?
So, like the value pointed by 8, so it's pointing to some location in memory because we are using ampersand ref2. So, I'm no, sir, I think so. I misinterpreted the question. Sir.
Okay, right. So the answer is one of you said that answer, I mean the right answer. So it assigns, now initially A was equal to 8. I mean initial assignment A was equal to 8. Now A will be equal to 2, the value of B, because reference 2 is nothing but alias of A. So it's as good as writing in place of reference 2. I mean you can just scratch this off and say A equal to B, because ref2 is a alias of A. So A equal to B. What do you mean by A equal to B? A is initially 8. So 8 will now change to 2. Getting it? So that's the way you are supposed to read it. So assigns 2, the value of B to A, and does not change the reference. So we expect that the reference will now point to B, or ref2 will now be aliasing B. No, that's not true. ref2 will not be able to redirect or re-alias or re-reference another variable or reassign another variable. Okay. So another point was with respect to reference variables. So you cannot initialize a reference to a constant object. So see what happens, or look at this statement now. So it says, what do you mean? I mean, how do you read this now? X is a integer which is constant, right? X is an integer which is constant. That means X is always 4. You cannot change X. That is the meaning of the first statement. It's a constant. Next statement, what are you doing? You're creating an alias. Reference 1 is the name of the alias to X. You're trying to create a reference 1 by named reference 1, I mean reference variable by name ref1 to X. So that cannot happen because X is already a constant. Why you can, I mean, what is the problem? See, using ref1, I can use X or ref1, right? I can access that location using the direct name X or ref1. Now, only when you use direct name X, you will get to know that X is a constant. Whereas if I use ref1 and try to manipulate the same value, it is possible. Agreed. So therefore, this is not allowed in C++. So it says the reason is violate variable X's constantness. So using the alias, you can change the value of X, which will violate the rule where what you have declared saying X is constant, but you will be able to violate via ref1, means you will be able to access that same location using ref1, and there is a chance that in your program you will make ref1 equal to 10. So effectively X becomes 10. Whereas the first statement says X is constant always 4, but you have changed the value of X to 10 via ref1. So this chance exists. So therefore, you cannot initialize a reference to a constant object. Clear? So can we do this? So I have already an integer A which is constant and the value is 5. Next, what I'm doing, I'm creating a reference variable ref2 of int type, which is again a constant, and I'm equating that to A. So I'm saying I have created an alias to A called ref2, and that is also constant. So is this okay?
Yes, sir.
Yes. So this is okay, because you are saying that reference to this alias is also a constant. So therefore, by writing this constant here, the REF2 will also make sure that you will not be able to manipulate the original value of A, which is 5. So 5 cannot be changed, but you can access. So it's an alias, as simple as that. But you cannot change. A always remains 5. This is allowed, whereas the first case is not allowed. So reference 2 is a reference to a constant value. That is second example I'm showing you. I'm reading about. So REF2 is a reference to constant value. So a constant reference treats the value it is referencing as constant. So no issues. Whereas the first one is illegal. The first example was illegal. So look at this example now. Int n equal to 5. So I have a variable n equal to 5 of integer type. So next I'm saying I'm creating a reference variable ref3 equal to n, and it's of const type. Look, is this possible? Can I make ref equal to 6?
No, sir.
No, right? So you cannot do this because you have already mentioned that it's a constant. So you cannot change. It's illegal. Ref3 is constant, so you cannot change the value. Can I make n equal to 7? Is this okay?
Yes, sir.
Right? Agreed. So because n is saying it's not a constant, n is not a constant, so therefore I can change n. But I cannot change the same value of n, the same location I cannot change via ref3. So that's the simple idea. So I hope these things are clear. So now coming to this very simple example, the complete program is shown to you now. In few slides further coming, going further, the complete program is here. So which will try to compare a simple program which tries to compare call by value, call by reference with pointers, and call by reference with reference variables. Using pointers and using reference variables. The three methods: call by value, call by reference, and call by pointers. So, call by pointers or using pointers, whatever you call. So all the three are shown here. See, observe that there are three different function declaration. All of them are simply doing a square of a number. So x, y, z, these three are the numbers. So I'll pass x to pass by, this call by value. I'll pass y to this one, the call by second function, and the last variable for the last function. So there are three functions, there are three variables. What they're doing, just a square of the number of square of x, square of y, and square of z. As simple as that. Observe the program. Integer is the return type, square by value, and integer is the parameter type. Next two functions, if you observe, both are returning void. You try to when you reread this again or go through this topic again, you try to go through the statements that were there in the initial slides. The one of the statements said the return address is return type is not required and things like that. So therefore you can observe that it's already void, so there is no return value. So both are void. So square by pointer, so int star, and next square by reference int address of. Sorry, okay, here it should be reference or ampersand, int ampersand. Okay, so go through the program main. So x, y, z are the three numbers. Then cout x equal to, so you print the value x before square by value. So what is the value? 2. So value returned by square by value. So you call this x, you call this function square by value using x as the parameter. So what you will get? 4, right? The 4 will be returned by that function, and you will be able to display that here. Observe the three functions, particularly the the parameters. One is int star, and one is int ampersand. And also observe the return type. One is int, the other two are void. All the three are doing the same thing. Squaring of a number. Coming to the next two topics, or the next two functions, square by pointer and square by reference. So y is taken for square by pointer, and observe how it is called. Address of y, because it's pointer, so I have highlighted here address of y, whereas here square by reference you are simply saying, I mean, using z. Getting it? Observe the parameters. So one is address of y, one is plain z. So finally, this is how the functions will be looking like. Square by value, the easiest one. A equal to A into A. So return A. Simple. Square by value. Return A. So A, the new value of A gets returned. Observe square by pointer. So what you sent there, that is when you called, was an address of y. Pointer, address of y. So therefore here you receive that using a pointer. Then you are saying the contents of B pointer equal to contents of B pointer multiplied by contents of B pointer. So you multiply and put that value over there, and you need not return anything. Already the same, this value gets copied into the original address. So done. Coming to the last one, square by reference. Int. So you have a reference variable here, or an alias here. Address cref. So this is the alias for z, because there what you sent was z. See here, z you have sent, and that's the alias here. So cref equal to cref into cref. So as simple as that, and nothing to be returned also. So because cref is an alias of z, so z equal to z into z is what is happening. So just comparing the what do you call, all the three ways in which you will be able to access the values. Okay. So I have color coded with blue because they look similar. A equal to A into A, cref equal to cref into cref. See, no confusion. Whereas this pointer method, you have a lot of stars there. Of course, it's not very difficult to understand, but for some of us, initially it might look like little tough or something very difficult to follow. But there, all the three are very simple. Okay, is this clear? And this is the output. Any questions or any confusion? So this simple program will be able to clearly distinguish and clearly give you an idea about how to use, that is how to pass parameters as a pointer, as a reference variable, or as a value, and how to receive them at the function, and then how do you process them. Everything is very clearly and simple program which will give you the idea. So I hope this is clear, and we also got introduced to reference variable. Right. So we'll go to the next topic. Which is functions in C. Are you able to see the slides?
Yes,
New
sir.
slide?
Yes.
New slide?
No, not
the last one. Okay. Yeah, now there are, now this is a new slide. So it's visible, right?
Yes, sir.
Right. Okay. So functions in C++, few things might be repeating. I don't know, depending on the individual. So therefore, I'm trying to cover everything, whatever is required. Okay. So some of the points might be known to you. Even otherwise, for somebody who is a beginner, there is no issue. You can still easily follow whatever is done. So functions in C++. So the first point or the first topic is prototypes, function prototypes. That is, how do you write and what is the meaning of function prototypes? So function prototype will have these things. That is, function prototype will have function name, parameters. That is what function will take in as parameters. And C++ is strongly typed. So you have to send the right parameters and the right type. The type in the sense whether it is integer or a string or a floating point number or object or anything. So you are supposed to send the correct parameter. So if you try to pass a wrong parameter type, then it will give an error. Okay, that's the meaning. That's the meaning of C is strongly typed. Means it's very, very particular on the data type when you try to pass parameters. Then return type. So you will specify all these things in a function. That is, one is function name, one is parameter list, and one is the return type. So type of information the function passes back to the caller. So default is int. So if you don't specify anything, then it is integer. So if you don't want to receive anything, you are supposed to write void. Otherwise, if you don't write void, that means probably it is X. Return type is integer because the default is integer. So void signifies that the function returns nothing. So that is what I was talking about. So void signifies that the function returns nothing. So this function prototype is needed only if the function definition comes after the function call in the program. So this prototype is needed only if function definition comes after the function call in the program. But it is good to use. It is good to use a function prototype. So this is an example. So look at the three things. That is function name. The function name in this example is maximum. Parameters. There are 3 integer type parameters. Return type. There is 1 integer return type. So you can simply say that this function takes 3 integers and returns an integer. Function definition. So that was declaration or parameter. I mean, sorry, what do you call prototype? So this is function definition. So function definition, you have a header and the body of the function. So in functions, you have 2 types. One is value returning and one is nothing. I mean, that is no value returning function. So let us see this first example or the first type, which is value returning functions. So return data type, you mentioned that here, then function name, then parameter list, then all the statements that you have, that's the body, constants, variable declarations, other C++ statements, and return value. So this is the value returning functions generic body. Into the second, which is non-value returning function. So you will have a void instead of any return type. So you have void, then function name, parameter list, and all that. And there is no need to write the return. So the end of the braces will mean that it is the end of the function. Next is about the formal parameters. So the meaning or the definition of formal parameters. So the argument names in the function header are referred to as formal parameters. So observe this example, find max between int x and int y. So that is what is this function trying to find the maximum between x and y. So which variables are the formal parameters here? Sorry, which variables are the formal parameters? So the definition says argument names in the function header are referred to as formal parameters. So can you tell me which variables are called formal parameters in this example?
X and Y.
X and Y, right? So they are called formal parameters. X and Y are called formal parameters. Now coming to function signature. So this is one important topic or important concept in C++, which is function signature. So a function's signature include the function's name and the number, order and type of its formal parameters. So look at that definition very clearly. So the signature include the name, the number, order and type of parameters. Means how many parameters, what is the order of writing those parameters, and what is the type of those parameters, the formal parameters. All this will form the signature of the function. All this will form the signature of a function. So as an example, so these two functions that I'll show you, the functions will have the same signature. Int divide int n int m. So another function which is double, means it's returning a double, and the name of the function is again the same divide, and it is also going to take two integers, int n and int m. So these two functions have the same signature. Why? Because the function name is same. The first point which function name. So both have divide function names. The number of arguments. So both have two arguments. Arguments are parameters. Both are one and the same. Okay. Parameters is n and m. Two. Number of parameters are two. The order int comma int. Int comma int. The order is also the same. And the type also same. Int. Right? So therefore, even though the return type is different, one is int, one is double. So as per the definition, so return type is immaterial. The name, the parameter list, type and order. So that is more important. So therefore, these two functions have the same signature. Let us take one example of the function of a function which has a different signature. Int add float comma int comma int. Int add int comma int comma int. Int add int comma float. Right? So all these three functions will have unique signatures. First function signature is different, second is different, and third is different. So they are all having unique signatures. Because even though the name is same, but the type of parameter is different. So there is a float which is coming up here and there, and in one of the functions there is no float at all. Getting it? So are you able to understand what is the meaning of function signature? Yes. Yeah. Now next is how to call a function. A function is called by specifying its name followed by its arguments. So that's as simple as that, right? We have already seen few examples of calling a function, and we know also how to call a function. So as I told you, I assume that you know at least C or any other programming language. So almost in every programming language, calling that is function calls are very similar. So again, differentiating between non-value returning functions and returning functions. So for non-value returning functions, you just have to call the name, that is use the name and pass the parameters, data passed to the function. If you have a value returning function, then you have to say results equal to, means it returns a value, no? So that value you are supposed to store somewhere. So therefore, you will allocate some space accordingly, and then you say results. I mean, as an example, it's in this question, I mean, in this PPT slide, it is results. Results equal to function name and parameter list. Argument list or parameter list. So one is non-value returning and the second example is value returning. Right. So let us take another example and identify all these things. That is function prototype. Very clearly it is mentioned on the top. Int find max int comma int. So that's called function prototype. Then you are calling the function here. It's again highlighted here. Max equal to find max first num comma second num. So you can also observe that first num comma second num are okay. We did not mention the definition of actual parameters. So it's coming up now. Anyhow, first num and second num are actually, they are called actual parameters. Okay. Yeah, this is the point. The argument names in the function call are referred to as actual parameters. So which are the actual parameters? These two, first num and comma second num. That is first num and second num. If first num and sec num. So these two are called as actual parameters. So now which are the formal parameters now? Can you tell me, identify what are the formal parameters here?
A and B.
A and B, right? A and B are formal parameters. First num and second num, they are called the actual parameters. So this is how you call a function, and this is how you write a function prototype. So calling a function by value. So what is the meaning? So in the previous, few minutes ago, what we studied for calling by a function by value, pointer and all that, we just saw the effect, how to use and what is the effect. Function call by value. So what is the use and what is the effect? So here we are trying to observe a little more details. So when you call a function by value, the function receives a copy of the actual parameter values. So that's the first point. What happens? We are trying to understand what happens when you call a function by value. So the first point is the function receives a copy of the actual parameter values. The function cannot change the values of the actual parameters. So we'll take this example to understand these 2 points. We'll take this example. Just observe here, pass by value is the topic, or is the concept that we're trying to look at. And this is the function FOO, int I equal to 7, BAZ of I. So this is a function, and inside this function, you're calling this function BAZ. And look at BAZ. BAZ is another function which takes in a integer type, and j equal to 3. So this is some useless function. Just try to understand the concept. Okay. So what will happen when you execute the first function? So base of I. So what passes to the BAZ function is I, the value I. So because I is a local variable, right? I hope we are all familiar with local variables and global variables. Even otherwise, I think it will be taught in a few maybe next class or somewhere that time. So local variable means whatever, as a very rough definition, I'm telling you, local variables are those variables which are declared inside a function. Like here, this is a function, right? FOO, that's a function. I is declared inside the function because of this braces. So int I equal to 7. So this was where it was declared, int I equal to 7. So therefore I is a local variable. Whereas if I put this I equal to 7 on the top, that is outside the function, if I write int I equal to 7, then I becomes global variable. Okay, so just a very simple point that I mentioned, local and global. So since now in this case I is a local variable, the local variable stays in that function. Whereas a copy of that, which is 7, the value 7 is passed to j. When you call BAZ of I, 7 is passed to j. So think of this as a declaration with initialization along the lines of int j equal to what BAZ has passed. So what BAZ has passed is 7. So that 7 comes over here. The value 7 comes over here. Next, inside the function, what you are doing, inside the BAZ function, what you are doing, you're simply writing j equal to 3. What is j? Is j a local variable or a global variable? Look at the program. Is j a local variable or a global variable?
Local variable.
Local variable, right? because j is a part of the function void baz. So j is a local variable. So what happens? There will be some memory. In that memory, the value 7 goes and stays. The value 7 goes and stays in that local memory. Then what you are doing? J equal to 3. Look at the next statement. That is the only statement that we have. J equal to 3. What will happen? In that local memory, the original value was 7. Now you are converting that 7 to 3 or rewriting the location. I mean, the contents originally was 7. Now your contents will change to 3. But where? It is in the local variable. So therefore, nothing is getting affected in the original I. Okay, that's the meaning of this, or that's the whole idea of pass by value. Means no changes will be made in the original function or values in the original function. Are you clear? So 7 is changed to 3, but that is only in the local of this function baz, local variable of this function baz. But once you return here, original value of I equal to 7, so that remains. Getting it? So that was call by value. Now calling a function by reference. Trying to go into the details, a little more details. So very useful when we need a function which returns more than one value. So this is what we studied in the previous topic also. So the formal parameter becomes an alias for the actual parameter. The function can change values of the actual parameters. Right? Is this clear? So because of reference variables, so you will be able to access the original variable using the alias. So effectively, you will be changing the original values or the actual parameters. So look at this example, calling a function by reference. So you can easily observe this function prototype void new value equal to float ampersand float ampersand. So there are two floats that are taken, or reference to floats that are taken as parameters to this new val. Look at the program. The user has to enter two values, first num and second num. Those two values are floating point because float is also mentioned in the main program. So float first num, second num, SEC num. So first num and second num both are local to main. Agree? Both are local to main because they are inside the flower braces. So both are local functions to, local variables to the main function, first num and second num. So you read the values. That is what is shown here. C in first num comma second num. Next, you call the function, this function, new val first num comma second num. So you go here. You go here and you try to get these values and print the values. And observe what you are doing. X num equal to 89, so that is 89 and a half. Y num equal to 99 and a half. So what will happen? The original first num and second num got changed to 89.5 and 99.5. Agreed? So whatever value you feed here, because C out enter two numbers, C in it takes first number and second number, right? Just observe the program. It takes some two values, two floating point values, but what it prints in the end is always a constant. That is 89.5 and 99.5. Just an example of showing the calling a function by reference. Now coming to pass by reference. Same function, a small change compared to the previous this thing. That is, I have introduced ampersand, int ampersand j equal to 3. Following? Just observe the difference now. Now what will happen? You are sending 7, the value 7. Are you sending the value 7? compared to this and the previous. So in the previous example, it was pass by value. The 7 was copied here. Now what gets copied? Will 7 be copied or something else will happen here? So something else will happen, right? So that is you're saying int ampersand j, that is reference variable you have used. So j is a reference to a reference variable or alias to I. So when you say j equal to 3, effectively you're actually saying what? I equal to 3. So even though I is a local variable, still I can change the content of I from the other function, which is baz. Getting it? So 7, the original value 7 now will be equal to 3, and there also it gets changed. Getting the difference? Pass by value and pass by reference. So whatever this effect, that is the original value getting manipulated, the same effect I can realize using pointers also. That is in C. I can do the same program or realize in effect the same thing using pointers in C. So that is what I was trying to tell you. How easy or how difficult it is using what do you call reference pointer? Sorry, reference variables. Okay, any doubts? I hope this is clear. I hope it is all simple and easy. So if you have any questions or doubts, you can ask. Right, so we will go to the next slide. Right, how function call works. So we are going into the details, means a little bit detail, not too much, but good enough, quite good enough detail. So these are the steps that will be done internally when a function gets called. So a function call uses program call stack or stack frame. Observe that a function call uses program call stack or stack frame. So function calls and stacks are very much related. Function call and stacks are very much related. How? Can anyone tell me how function call and stack are related? You should be knowing this because of your ARM topic, ARM, microprocessors. So can anyone tell me how function call and stack are related?
So whenever a function is called, the first of all the address of the called function or the calling function is stored, and the data of the variables in that function that is stored on the stack. And then if we are calling another function from the called function, then also a similar process happens. Like whatever data of the initial function is there is stored on the stack, so that when we come out of or when we go back to the calling function, the data isn't changed. The original data is protected as such.
Okay. Okay, to an extent you are right. I mean, yeah, you were not able to frame the right answer. That doesn't matter. What you said is almost right, or in fact entirely right. Anybody else want to answer or want to make it much more precise? My question was how stack and function are related. I mean, what's the connection between them? Function calls and stack.
So the last function that is called is executed first, and the first function call will be finished at last. So it perfectly fits the stack data flow.
Right, correct. So stack follows the principle of first in, last out, right? Whatever you push into the stack first will be the last to exit or last to get out. First in, last out. The same idea works with function calls also. Initially, what is the first function that you enter? Main. So from main function, what you do is you will call, say, function 1. Once you enter, once you're doing function 1, let us assume that you call function 2 from function 1, obviously, right? You're executing function 1. So while executing function 1, what you will do is you will encounter another call to function 2. So while executing function 2, you will probably call to function 3. And let us assume that there are no more functions. So which function will you exit first? Or which function will you finish first? As somebody pointed out, it would be function 3. Function 3 will be finished. Then function 3 will return to function 2. Once you finish function 2 will be returning at the end. It will return to function 1. Then function 1 will finish and then you will return back to the original function or the main function. Main is what you entered first and main is what you will exit in the end. So once you finish main, then only you will exit main. So which one did you enter last? F3. Function 3 you entered last, but that was also the function which exited immediately or the first. So first in, last out, or last in, first out, whatever you call, both are one and the same. So this is the relation between function and stack. I mean one of the relation. Then another relation, because of this link or because of this similar picture, what happens is whenever a function gets called, there will be a program call stack or a stack frame that gets built in the memory. There is a small stack frame that gets built in the memory. So what is a frame? A frame will have all the values, means parameter values, basically parameter values, whatever you have sent, and the return address. All that will be a part of the frame. That frame is pushed on to the stack when a call is made. Then execution jumps to the function's code block. So it will go to the code. Then it starts executing that called function. So once the function code block is executed, the execution returns to the statement just after the call statement. So once you return back, the frame is popped automatically. So what do you mean by frame is popped? So your stack gets adjusted and therefore variables are also unaccessible or destroyed. I mean, basically it does not destroy, right? So they seem to be unaccessible because stack pointer changes. So all your stack will be whatever the extra stack that was built on will become unaccessible. So basically that is what you want. So remember that whenever a function is called, a stack frame gets built or a frame gets built. And a frame means in memory you get a stack, things in memory. So what do you put in those stack or in that stack? What do you put? All the parameters. Suppose I call a function, say add a comma b comma c. Then a, b, c are parameters. So these three parameters will be a part of the stack frame. These three parameters a, b, c will be a part of the stack frame. Apart from these three parameters, return address will also be a part of the stack frame. Getting it? And the moment I come out of this function call, the return address is also not required because I have already returned, and the ABC values, the function parameter values, they are also not required because they are dead. I mean, you returned you came out of the function, so effectively they are dead variables. So you have popped out from the frame, or the values are popped out of the stack. Simple and clear. I mean, this is how the program call and return are organized, and the relation with call and return with stack. Now, this is another important point which we are supposed to observe. Now, this call, that is stack frame getting built and stack frame getting popped. These steps, or these two steps, that is you build a stack and then you destroy the stack, or that is you basically pop out of the stack. These two steps will incur a performance cost because processor has to do that, right? Apart from running your function, processor has to do these two tasks. Push and pop. It is supposed to do push certain bytes of memory onto the stack and pop certain bytes of memory out of the stack. So therefore performance cost is involved. So this incurs a small performance cost. What is that performance cost? Just now I told you, copying the arguments and the local variables onto the stack. stack frame management. So you're supposed to adjust your PC and all that, manage the stack frame, and then copying the function's result back out of the stack frame. That is, if you say return something, then the result is also actually stored in the stack, the result. So the moment you are trying to exit, you will also copy that result from the stack onto the original location or to wherever is your destination. You will copy that. Getting it? So a lot of data gets pushed and a lot of data gets popped. So there is a small performance cost. So this point you remember, this point of performance cost we will be using in a later point of time, but that's a general information that you should be knowing. Okay, so now coming to default arguments for functions. So this is something new in C++. C did not have this idea of default arguments. So we can provide default arguments for, default values for some arguments. We can provide default values for some arguments or even for all arguments. So if function parameter is omitted, it gets default value automatically. I'll show you with an example. Later on, when you read these points, you will be able to relate that example with these points. So if not enough parameters are specified, rightmost goes to the default. So caller does not have to fill these. So default values are specified in the function prototype. So how do you specify the default values or the default values for the arguments? They are specified in the function prototype. So required versus default arguments. So take this example. So function with required argument, void foo int a, and this is the function. This is the declaration and this is the definition, function definition. So I can call this as foo of 2, and it prints 2 because simply if you observe the program, the function, it's simply printing the value, prints the value 2. Now this had no argument, no default argument, or right, you are supposed to give the value or the argument. In this example, if you observe, just observe the prototype or the definition, declaration is little different. Void foo int a equal to 3. So here a equal to 3 was not there. Here a equal to 3 is made. So that means this is the default value of a equal to 3, a. The value 3 is the default value for the argument a. And the same function definition is there. Now what happens? If I simply call, if I call foo of 2, then it will print 2. And if I don't send any argument, if I simply call foo without any arguments, then it will print the default value, which is 3. Or it will use the default value, which is 3. Clear? Simple. These are very simple topics. Okay. Defaults with multiple arguments. So in the previous example, it was only one argument. Here now it is in multiple arguments. So function with one of the two arguments defaulted. So just look at that. Void foo int a comma int b equal to 3. Then there is the function definition. So I can call foo of 2. What it will do? It will print 2 comma 3 because default value is 3 for b, and this passed down value will be 2. The 2 will be for a. So it becomes 2 comma 3. So I can even call as foo 2 comma 4. So the default value 3 is now overwritten by 4. So it prints 2 and 4. So same function, another example, same function with both arguments defaulted. A equal to 1, b equal to 3. Same function. So then next, if I call as foo, that is no arguments being passed, then the default values will be taken 1 comma 3. So prints 1 and 3. And if you pass one of the arguments, then that argument will be taken as the leftmost argument, and the rightmost arguments go for defaulted values. Rightmost argument go for default values. Leftmost argument will be taking your values. So you can call FOO of 2, print 2, 3. Clear? Simple. Function call with default arguments. So I can even call completely both the arguments being different. One is 7 and one is 8. Possible. So another example of using default values. So this is the program. Entire program is here. You can even try this later in your home. So this is giving the default values. If you just observe the program, box volume. So there is a box, what do you call, object or class with having, sorry, not class here. This is just a function, right? So box volume, it's a function which is having int length equal to 1, width equal to 1, and height equal to 1. So these are default values, 1, 1, 1, length equal to 1, width equal to 1, height equal to 1. So you're trying to call this function in 3 different ways or 4 different ways, and every time you get a different answer. So you can just observe that. Quite simple. So this is the program expected output, and that is what is shown on the screen. So as I told, you can look at the program, quite simple program. You can even understand the results immediately. Otherwise, you can even code it for your purposes. You can type this program and again check the results on your own. Not just checking the results or not just typing the same program. What I usually tell to my students is that they are supposed to do some kind of manipulation in the original program and try to see the results. But before seeing the results, you are supposed to analyze and predict the result. Analyze your question or analyze your program and predict the result. Okay, so if I made this change, then this should be the answer. And if your answer matches with your prediction, that means your understanding is right. If your answer is not matching with the prediction, that means there is something wrong in your understanding of the program, of the behavior. So that is the very easiest method of understanding or writing programs, learning to write programs. So write a program, guess the answer, and run the program and see the answer. So if it matches, that means you are on the right track. That means you have understood the program concept. So if your answer is not matching, something is wrong. Try to find out. Otherwise, you can meet us. This is the program output. So default argument limitations. So there are a few points that you are supposed to remember when you use default arguments for functions. So watch out for ambiguous signatures like this, FOO and FOO int a equal to 2, for example. So both are ambiguous. Like if you try to call in your program, if you try to call FOO without any arguments, then should it go here or should it go here? Getting it? Are you able to follow the confusion? So compiler will also be confused whether the function call is for this or this, the first one or the second one. So there is an ambiguity. So such ambiguous signatures will not be accepted. So another point was only the rightmost arguments will go for default. So you cannot declare like this, void FOO int a equal to 1 and int b. So you cannot do like this. The default values should be supplied to the rightmost end first. So and caller must supply the leftmost arguments because default go to the rightmost side. So the caller must supply the leftmost arguments. Quite simple and clear, right? So now coming to the next topic, which is function overloading. This is probably again for some of you might be repeating, but I hope there is something new for others also. I mean, for those who are who you feel it is repeating. So having functions with same name but different parameters is called function overloading. Different parameters is basically the function signature what we defined. So that is related to the function overloading, function signatures related to the concept of function overloading. So look at this example. So there might be functions with the same name. So because you have given the same name, that means they are performing similar tasks. So function, for example, square. I can have a function called square for integers. I can have a function called square for floats. So it's also shown here. So look at this first function, square, integer. It is taking integer. Second function is square, but it is taking float. So they are similar looking functions. So same names, but different parameters. So how will the compiler choose between the two? So the compiler chooses between the two by looking at the signature, the function signature. So that's the reason function signature is very important. So look at the signature and check whether it matches with the integer or the floating square. So if the value that you are supplying is int type, then it will go to the int type square. Otherwise, it will go to the float type square. Right? Basically, it depends on the function signature. So another example, void ABS int x, void ABS float x. So there are two functions of the same name, but with different parameters. So look at the parameter type, one is int, one is float. So basically you are able to distinguish between the two. That you, in the sense, the compiler will be able to identify which one to call for which, which function should I associate for each call. So there is no ambiguity or there is no confusion for the compiler. So this is another example for the same thing. The square of int and square of double. So another example, so you know how to get the answer or what is the expected answer. Okay, so next topic is inline functions. So we just now studied that functions are based on call and return mechanism. We know that, but we also know that call and return will also be related to stacks. Anyhow, in inline functions are expanded inline at the point of each call. So we'll try to explain this. So there is no call and return kind of a mechanism in inline functions. Whenever I say inline functions, that means they are not doing call and return. You can keep that in mind in a very generic sense. So inline functions are expanded inline and there is no call and return mechanism. I'll show you with examples. They are similar to macros in assembly or C and C++. If you know what is a macro in the other side, then these inline functions are very similar to macros. So kind of copy paste coding. Inline functions is a kind of copy paste coding. So you can keep these points in mind. With an example, when we deal, you will be able to understand. So this is an inline function. So the word or the keyword is written here, inline int e1 of x. So return if not, that is not of x divided by percentage 2. That is, this is the easiest way to find whether the number is even or not. So next it says if even of 10. So this is the statement, if even of 10. That becomes what? Internally, that becomes if not, that is, it will, this even function will be simply replaced by its body. If not of 10 percentage 2, the body says percentage 2, so that same thing is repeating here. Similarly, even of 11 will get replaced by this way, percentage 11 percentage 2. So copy pasting, in the sense with values it gets pasted, kind of copy pasting the code. So there is no call and return. So similarly here, another example, double cube of a constant double. Okay, so return s into s into s. So because it is written as inline, so observe the keyword inline here also. Inline, the cube is an inline function. Cube is the name of the function, it's an inline function. So if that is the case, when I say x equal to cube of 10 in my C program, then it simply turns or changes to, the compiler will put that inline idea, and it will simply say x equal to 10 into 10 into 10, because it is saying simply return s into s into s. So it becomes 10 into 10 into 10. So it will be replacing, see, cube of 10 is the call. So this call will be replaced by this value or this kind of a statement in the call. So call gets removed. In place of call, the body itself gets pasted with appropriate values as shown here. Clear? Inline functions. So what's the advantage of having inline functions and what's the disadvantage? Yeah.
Excuse me, sir.
Yes.
Can we say all recursive functions are inline?
No. We should not do. We should not use recursive functions. We should not use the idea of inlining for recursive functions. That is what we were about to discuss, advantage and disadvantage. Recursive functions are actually not inline. Recursive functions are the regular function. They will do the call and return mechanism only. Okay. Recursive functions cannot be done inline. They have to be done with the method of that call and return mechanism only.
Because here also we are basically substituting a value. So that is what we do in recursion. Like we get a,
No.
until we get a test case, we replace, we keep on calling the function.
Okay, but still that the recursion, recursive kind of a call will always be done using the regular call and return stack frame. All that comes into picture when you do recursion. Okay, we will just try to finish this and then we can discuss if there is some time. Advantage of inline functions. So have no overhead associated with the call and return mechanism. I told you there is a small price to be paid. Performance penalty is there because you are supposed to build a stack frame, push, pop, and all that. So that overhead is removed. There is no such overhead in the case of inline functions. That's one advantage. So therefore, because you don't have the overhead, so you will have smaller runtimes for these inline functions compared to the normal function calls. And they are safer than parameterized macros. So there is something called as parameterized macros in the case of Mac. As I told, they are similar to macros, but they are much more better than macros. Inline functions are better than macros, it says, or safer than parameterized macros. Disadvantage: should be used with small and often used functions. If they are too large and called too often, the program grows larger. So this is the advantage. If you have 100 times, if you are using that call, the function call, and if that function is an inline function, by definition, if you write inline, then it will try to copy paste 100 times. So your code becomes larger. You are simply magnifying your size of the code. So they become too large, and if they call too often, then the program grows larger. Too often in the sense, suppose you have called it 100 times in your program, then all the 100 times it is copy pasted. So your program size is simply overloaded 100 times. So many number of times. So that's the disadvantage. And advantage is that, if you see the other way, if it's a small program, just like how the previous examples that I showed, cube or square, just one statement or two statements, then it is good to use inline. Small and regularly used means every time you are using that, then better go with inline. But on the other side, if it is too large program and very frequently used, then it is not a good idea to go with inline. Okay, few more points on the inline functions. Inline specifier is a request, not a command to the compiler. So the keyword inline was there, no, before the function name inline you were writing. So that inline is a request and not a command to the compiler. So some compilers will not inline a function if it contains a static variable, a loop or a switch or a goto, a return statement, and if a function is recursive. So somebody asked about recursive. So this is the point. So it clearly says that compiler won't support inlining a recursive function. And inline should be used very carefully when inline functions are called recursively. So that's the reason compilers will not accept your inline request if the function is called recursively. Automatic inlining. That is, if you define a member function inside the class declaration, it causes the function to automatically become an inline function. So I'll show you with examples. So in this case, the inline keyword is not necessary. However, it's not an error. So restrictions are the same as normal inline functions. This is the automatic inlining. So I have a class. So you can observe that open and square braces of the class, my class, open and square. So that's the class definition. And inside the class definition here, if you observe, there are three different functions: my class, set a, get a. All these three functions are now inline functions because they are inside the class definition. So they are automatically inlined. See the second example on the right side, explicit inlining. So what you have done, you have the class definition, but you have written the function outside the class, but you have used the keyword inline. So therefore it is explicitly inlining. Clear? Class definition is here, but the function definition is outside the class. So therefore you are writing inline, therefore you are effectively making it inline function. Here it was automatically inlining. So inline function example, int sum, so written a plus b. Print sum, that is another function, print sum, and here you are calling the sum, int r equal to sum of 5, 6. So just simple program, look at that program. So this is without inline. There is no keyword inline, so therefore this is how it looks. Now look at this same program with inline. So the keyword is there, inline keyword. So same function, that is sum of 5, 6 if I do, then the compiler will replace the function call with the body of the function, and thus the resulting binary will be something like this: void print sum of int r equal to 5 plus 6, print %d \n r. Clear? So it is inline in the sense the body itself gets pasted here. So that's the end of the topic. So any questions?
Sir, by any chance, can we force inline a function? Like we have to inline the function?
No, that is what the point clearly mentioned. You can request and compiler will decide whether to inline or not. It depends on compiler also. There might be a compiler which supports force inlining, but this is general trend or general point that I have mentioned, that compilers won't accept that as a forced this thing, but it is a request. But there is a chance that some compilers might be written for a particular purpose, and might be that compiler supports inlining with force also. But that's not a good idea. I told you, no, so for certain reasons, inlining will not be a good idea. I mean, it is good for certain purposes and not good for, or it works good in some cases and it does not work good in some cases. So based on that, we should take decision. Based on that only the compiler is taking the decision.
Okay, sir.
Yeah. It will look at the situation where it is easy or it is good to have inline, it will go for it. Otherwise, it won't do. Yeah. Any other questions? So was this all known to you or something was new? I mean, can anyone tell me anything new you studied today, or all this was revision?
So most of it was known. The
Okay.
inline function, for example, I didn't know some of the points, so
Okay.
that was new to me.
Okay, and that function stack pointer, stack frame,
Yes,
all that.
that also I kind of knew, but it was a revision, that part.
Okay, so this is only one answer. What about others?
So most of it was known, sir.
Okay. Right. Okay, I got two answers where most of it was known. Any one of you who says everything was new or most of it was new at least? Okay, doesn't matter. So point is, see, if we start asking questions, then you will not be able to answer. But when we start explaining, then you will say that everything was known. We don't know how to understand this situation. Okay, right. So if there are any questions, we will take it now. Otherwise, we will close it. So no questions?
No, sir.
Yeah. Okay, right. Thank you. I think
Thank
from
you, sir.
next class, Madam will be continuing. She will be taking few topics. Then I'll return back.
Okay. Okay, sir.
Yeah. Right. Right.
Okay, sir.
Thank you.
Thank you.
Yes. Thank you. Thank you.